The Greenland ice sheet is the biggest ice sheet that remains on the northern hemisphere, and it holds an equivalent of about 7.4 meters of sea level rise if you would melt it completely. So in the 1990s, actually finishing 1993, the GISP-2 ice core program drilled through almost 2 miles of ice and retrieved arguably one of the most important climate records that we have, the GISP-2 ice core. And that's why it was so pioneering. They kept 2 miles of ice intact, and we could do the climate analysis. And after that, they drilled underneath the ice into the bedrock and retrieved 1.5 meters of bedrock. That is now the basis of the study coming out. What distinguishes this study from anything else that we have done in terms of ice sheet stability so far is that this is the first study where we have direct access to the geological samples that tell us about the history of the ice sheet. So if we lose that ice sheet under natural geological forcing, and given the man-made heating of the planet that we are watching now, we have to be prepared that this ice sheet might go again, and it might go again soon. And we are already committing to just a substantial amount of sea level rise, substantially higher than in most predictions. And now in this paper, you also line out the next step of experiments and model simulations that is necessary to inform us in more detail when this ice sheet will melt and at what rate it will melt. This is doable. This is just really a question of funding at this point. But these are information we need to know as a society, and this information would give the baseline for policymakers and decision makers to prepare the United States and the entire world for this rate of change that is coming. And the rate of sea level rise, unfortunately, seems to be higher than we have it in the predictions in the moment.